Hi, everyone. We are not literally working on Star Wars, so we come in peace and we want to do science on the moon. And I want to talk about our mission that we are currently planning. And as you can see, there is something called Next Stop Apollo 17. So we want to go back to the moon, and we don't just want to go anywhere, but we want to go to Apollo 17. But the first important question to ask is, why are we doing this? And this guy is part of the answer. You probably know him, it's Charles Lindbergh. And there is something called the Lindbergh Boom. And so the thing is that in the beginning it was thought to be impossible to fly alone over the Atlantic. And so at one point, a guy named Ortiz, who was a hotel millionaire at that time, he created a prize to incentivize people to fly over the Atlantic. And there are many, many people, aside from Charles Lindbergh, that tried it. But Charles Lindbergh was the guy that actually survived it. And once he survived, this sounds very creepy, once he succeeded in flying over the Atlantic Ocean, people started to realize that flying has a purpose. It can be used for traveling. And so this created the Lindbergh Boom, which created the network of airplanes that you see today. So this was really the birth hour of public aviation. And there is something a little similar. It's called the Google Lunar X-Prize. And this was created by the two founders of Google. And they took some of their spare change that they had, about $30 million, and put it into the Google Lunar X-Prize. And the goal is quite simple. So all you have to do is send a rover to the moon, or some spacecraft to the moon, drive at least 500 meters, and send back HD video while doing so. And this is all you have to do to get the prize money, the $30 million. And we are one of the groups that is participating in it. And actually, we are the only German team that is still in the competition. We are Berlin-based, actually. So if you want to come and visit us, if you leave Berlin to the east, and you're in Brandenburg, then you go back 5 meters, and we're on the left-hand side. And so we have been working on this since about 2008, so that's quite a while. And it was Robert Boom who had the idea to found this team. So the story goes that he heard about it, and he was like, why should I do this? And then he heard that this is about making private space exploration happen. And he thought, this sounds like a really good idea. And he needed some money for the registration, and by chance, some guy pulled into his car, and then he got some insurance money, and so he was able to enter the competition. And a few barbecues later, it was decided that this is a really good idea to take part. And so we have been working on this for quite a while now. In the beginning, as our name suggests, as part-time scientists. So we all had our day jobs. I was a PhD at a university. Robert was working in IT administration. Some of our software developers. The other guy was working in medicine. But we set our goal to really do this thing. And yeah, this is what we did. And the plan is, well, November 27 is a bit optimistic, but we will launch by the end of the next year, or by the beginning of 2018, from not quite Berlin, but from probably Vandenberg. It's or Cape Town, Cape Canaveral, sorry. So all we need to do after we launched, with you buy a rocket, and then you're getting into Earth orbit. And then you just, cross the almost 400,000 kilometers, and this will take about 5 days. And then you arrive on the moon, then you just soft land, you disembark 2 rovers So we are sending 2 rovers, and then we collect the money from Google. I mean, this sounds like an absolutely failure-proof plan, right? There couldn't be anything probably going wrong. So in the beginning, we started with developing the rovers because they are simple. You can drive around in your office. And eventually, we also started to develop our spacecraft. And this is our latest spacecraft. This is really new. We just finished developing it, and we are currently in the process of building it. So this is the first commercial spacecraft that is going to leave the Earth's orbit. And it's really cool. The goal is to bring about 100 kilograms of payload to the moon, of which 2 times 40 are the rovers, and we will also bring some additional payloads with us. And it's designed in such a way that we can take the cheap rockets. So, and by cheap I mean, like 20 to 30 million. There are more expensive ones, but those are the ones that are easily available for commercial entities. So, this spacecraft, by the way, there's a reason why Robert Wimmer also couldn't attend. There is a press event going on tonight, and if you're a proper, excellent journalist, feel free to talk to me after the presentation. But the question is, why do we want to go to Apollo 17? We were not having a map of the moon and throwing a random dart at it. It was by choice. There is, the romantic part of it, and that is that, this was the last place where man was setting foot on the moon, and we are continuing the story for humanity. This is very romantic, but there's also a very pragmatic reason for it and a research reason for it. The pragmatic reason is that it's a very well-documented landing site. So we know that it's hard to mess up the landing because it's a very, very flat area, very little big stones, very little craters. Also, Apollo 17 was, unfortunately, the first mission where they actually sent a scientist. So the former missions were flown by Air Force hotshots, and they were not the brightest scientists. So in Taurus-Littrow Valley, they had the idea that maybe sending a geologist to the moon would be a good idea. And so they sent it to a geologically very interesting landing site, and this is one of the reasons why we want to go there. The other one is, and this is how it looks today. We want to see how it looks today, because there are some conspiracy theorists, and we will take pictures of it, and then they will be like, oh, no, you're bought by the NSA, so this is nice for that we know it's up there. The conspiracy theorists will probably not believe us, but we want to see how this stuff did on the moon for over 40 years. And in order to do that, we built a rover, and we call it the Audi Lunar Quattro, because we have been working on this mission in our part-time for quite a while, and then there was an interim competition where we have won $750,000, and with that we created our headquarters and office in Berlin, and then something really interesting happened. Audi supports our mission. So they are helping us to build the most awesome rover that you could imagine. So we are working with them technology-wise, they're helping us financially, and they helped us to reduce the weight of the rover by 10 kilograms, and this mostly by using 3D printed aluminum, which is pretty neat. And they also have very, very nice test facilities, and and also the rover is now very aerodynamic, which is totally irrelevant for the moon, but it looks very sleek. Also, I'm very proud to announce that this is the slowest rover, the slowest Audi you can buy. But it's most Audis are made for this world, and this is made for an entirely different world, so the comparison is not fair. But it's more expensive than some of the most expensive cars that Audi has. But it's really just not fun to drive at 3.6 kilometers per hour. It's like, but when we go to the moon, we want to do science, and one of the science experiments that we designed is actually the camera. So as you saw, we have 3 cameras in the head, and the outer ones are color images. So they make color images in 3D stereoscopic for driving around. And the middle one is a telelens, which has a black and white sensor. And in front of the sensor is a filter wheel. And this filter wheel allows us to look at different wavelengths. So we can do some material composition analysis by just looking at stones or materials. And what interesting materials are on the moon? Well, there is for one, there is the lunar rover, that is the vehicle that the astronauts were driving, and stories are that the key is still plugged in, so if you would jump in, it would still be there, and you could possibly drive it. We're not going to try that, we have your own car, but for future reference, if you happen to be on the moon, remember, go there. The cool thing about the lunar rover vehicles is that they are made from the most unspacey materials that you could imagine. So they are made from aluminum, which is really space-grade stuff, but they are also made from nylon and all the junk they had laying around. For example, the seats are actually some engineers' backyard seats that they had, and they were very lightweight, and so they're like, okay, and they put it there. And it would be very interesting to drive up to this rover and see how it did, because on the moon you don't have any atmosphere, so there is no wind going on. Everything stays the same as it was, and so there is one theory is that this looks really the same, but it could also be bombarded by micrometeorites, and it could be just a little something. Yeah, but we also want to we are not just taking our rovers to the moon and do science with them, we're also inviting others to bring science along with us to the moon. And one of the things we want to do is we want to grow a plant on the moon. So this is something that we are doing with Nether Ames, for example. It's a very small experiment. It's about CubeSat size, so it's 10 by 10 by 10. And there are some seeds in there. And once we arrive on the moon, they will be watered, and then they will grow, or maybe not. So this is the fun part about science, is that how that plants usually grow on Earth. So at 1 g, it works. And then you have, so at 1 times, gravitational, it works. And if you are growing seeds on the ISS, for example, where you have 0 g, things start to get a little strange. And you don't have any data point in between. So it could be like, this works, fucked up until 0 g, or it could be, this works, and then it, at 1/6 gravity, it still works. And so we want to see how that is really happening. And this is really interesting for one thing. So the ESA, the European Space Agency, actually wants to build a village on the moon, and they call it the Moon Village. Huh. They are not very creative. And we want to support them. And one of the things that all the science we do is about creating this vision. So we want to be able to provide the infrastructure for building the Moon Village, and be it with experiments, growing plants on the moon, or bringing some other experiments that analyzing the materials, like for water detection and stuff like this. One of the other things we want to do is we want to preserve the human knowledge, and we want to make a backup copy on the moon So a dictatorship backup copy of the Wikipedia on the moon, so that if aliens land on the moon and they find this disk, they can read it and be like, ah, this is how they messed up the Earth. And we want to store it on a crystal that's like this. And that's about our mission to the moon. I could talk for quite a bit longer, to be honest. But I guess some questions would be nice, wouldn't it?
We have approximately time for 1, maybe 2 questions, but thank you. Let's do this Q&A.
Okay, thank you very much for your presentation. One question. I just read, as many, the book on Elon Musk and the space company he has. One of his statements was that nowadays a lot of the technology being used in, let's say, almost households is good enough to use in space technology, and they are reducing the price of space technology by a factor 5, factor 10. You've presented stuff which looks like really neat, awesome, great, but the question is it also, are these things doing, Musk might say these things are doing too much, they're too nice, you just need to do what's necessary, low cost, competitive, and how do you feel about this?
Yeah, so one of the things, the factor of 10 is something that I found out is really very common. So one of the things we are cutting cost on our end is really by using not household electronics, but some selected components that are used in automotive parts, for example. And yeah, so essentially we are doing that. We are not using space-grade stuff for at least most of the stuff that we have. So the question is what factor of cost we are cutting. So it's really tough to answer, but our mission will be, you know, about if we would need to pay for all of that, would be about 60 to 70 millions. And the last mission that Airbus was talking about, which was really progressive, was about 680 millions. So a factor of 10 as well.
Wow, thank you. Yeah, so can I get a postcard when you're on the moon? Can we organize that? Can I give you my address or something? No? Okay, anyway.
Nah.
We'll see how it goes. All right, thank you. Big round of applause.